In this lecture, we will take a look how to solve specific problems using recursion.
Whenever we design recursive methods, we have to be very careful whenever we're designing and analyzing them. The main reason is we have to make sure that every recursive call eventually gets to a base case. Otherwise, we're going to get the issue of infinite recursion that we talked about in the last lecture. And as we mentioned, if we do get infinite recursion, we're eventually going to run out of memory. We're going to get abnormal terminations. Programs are going to crash. All sorts of bad stuff happens. So we do have to make sure that whenever we design these recursive methods that we do eventually get to that base case. If we want to design a recursive method, there are several things that we have to do. We first need to make sure that we understand the problem requirements. We need to understand what the problem is asking us, so that way we can come up with a solution to solve that problem. The next thing we have to be able to do is determine the limiting conditions. So for example, if we have a list, the limiting condition would be the number of elements in the list. So we have to know what our boundaries are. The next thing is to determine the base cases. So we need to be able to identify what those base cases are and provide a direct solution or a non-recursive solution for every single base case. As we mentioned before, there could be more than one base case, but there has to be at least one. But we have to be able to identify those cases and provide direct solutions for every single one of those base cases. And then finally, we need to be able to identify the recursive cases and then give a solution for each of those recursive cases. Now, specifically, these solutions have to be in terms of a smaller version of that problem size. Most recursive methods have several characteristics. So we'll mention 3 of these characteristics. So one of them is that they use an if-else statement or a switch statement that will lead to different cases. Most recursive methods also have one or more base cases, and they are, well, we mentioned they have to have at least one, but these base cases are used to stop the recursion. So normally we would say if we encounter a base case, we're going to return whatever the trivial solution is. And then the third characteristic is that each recursive call reduces the problem to a smaller version of itself. So we reduce the problem size by some amount. It could be just a little bit, we could cut in half, but every single time we make a recursive call, we should be reducing the size of the problem. There are several problems that we can solve using recursion. So the first problem we're going to take a look at is finding the largest element in an array. Let's suppose we have the following array. So we see here that we have an array of 6 elements, and they're all integers. So we have 5, 8, 2, 10, 9, and 4. Let's suppose we use the following notation to represent the array elements list A plus 1 all the way to list B. So we'll say list A with 3 dots, list B. I'm probably just going to say list A, list B, but let's just say that's the set of elements from list A all the way to and including list B. Now we want to find the largest element in the array. So let's suppose the list is of length 1. Well, in that case, list just has one element, and that has to be the largest element by default. Now let's suppose that the length of the list is greater than 1. So how do we find the largest element? So we're going to try to come up with a recursive approach. Well, let's say we want to find the largest element in list A to list B. So that might be the whole array, it may not be. But let's just say we're trying to find the largest element in this particular range. So what we could do is find the largest element in list A plus 1 to list B. And then once we find the largest element in that range, we'll compare it with the element in list A. So what we're doing is we'll find the largest element in the range list A plus 1 to list B, and then we'll compare that element with list A. So what this means is we can find the largest element in list A to list B by getting the maximum of list A and the largest of list A plus 1 to list B. So let's apply this to our example. So the list can be given by list 0 to list 5. So the largest element in the whole list is going to be the maximum of list 0 and the largest of list 1 to list 5. Well, what we're saying here is that the largest element in list is simply the maximum of list 0 and the largest element in list 1 to list 5. I know I just repeated that, but never hurts to review, right? All right, so we need to find the largest of list 1 to list 5. So if we do that, we'll just use the same formula again. And we can do this because the length of this list is going to be greater than 1. So we're allowed to do that. So that means to find the largest element in list 1 to list 5, we would then need to get the maximum of list 1 and then the largest element from list 2 to list 5. And we would just keep repeating this, where we would find the maximum of some list item and then the maximum of some range. And eventually we're going to get to our base case, and then we can work our way backwards. So notice with this example that every time we use the preceding formula to find this largest element in a sublist, the length of our sublist in the very next call is reduced by 1, because our original call was to find the maximum from list 0 to list 5. The next time we made a call, we were trying to find the largest from list 1 to list 5. So we cut down the number of elements we're looking at. So eventually what's going to happen is our sublist is going to be of length 1 if every time we make a method call, we reduce the size of the list by 1. What this means is if the length is 1, then the sublist only has 1 element. So for that particular sublist, that element has to be the largest element. So what would happen from this point onward is we would backtrack through all the recursive calls, comparing the largest element from that previous sublist with the first element of the new sublist. So if we just keep working our way backwards, we'll get back to our original problem where we would compare list 0 with the maximum or the largest of list 1 to list 5. Let's take a look at the Java code for solving this problem, and we will see that this is a recursive method. Well, we first need to take a look at the base case, which is done right here. So let me just circle this. Okay, so our base case is if our lower and upper are the same. Now, what are lower and upper? Well, when we call the largest method, we can specify the range that we want to try to find the largest of. So if we were to use our earlier example, we would call largest for our list, and then we would pass 0 and 5. We want to find the largest element from 0 to 5, which would be the entire array. So lower is our lower bound, and upper is our upper bound. Or if we want to use the notation we talked about before, think of lower as being our A, and upper as being our B. So if they're the same, then that means there's 1 element left in the list. So we're just going to return that 1 element in the list. Now, if this is not true, so the else portion is handling the case where our list has more than 1 element, we're going to call this line right here. This is our recursive case because we're going to call largest, but now we pass lower plus 1 instead of lower as our second argument. That way we would actually, in this case, find the largest of A plus 1 and B if we use our A and B notation. So that's eventually going to give us the largest element in that range, and we're going to store that in this max variable. And then the rest of this code right here is going to take care of comparing our list A with the maximum. So we check to see whichever one is the maximum, or whichever one is larger of the two, we're just going to return that value, whether it is the list lower or list A, or if it's the maximum of the rest of the list. Let's use our earlier example and see what happens when we call this method. So we call our largest method for the entire list. So our second argument is going to be 0, and our third argument is going to be 5. So that way we try to find the largest of the entire list. We find that 0 does not equal 5, so we have more than just 1 element in the list. So we're going to call largest again, but this time we're going to pass 1 as our lower bound. So then we run the method again. We find that 1 does not equal 5. So we'll call the method again, but this time we're going to pass 1 plus 1, which is 2. So we want to try to find the largest from 2 to 5. Well, we see that 2 does not equal 5. So we're going to call it again with passing a 3. So we're going to try to find the largest of 3 to 5. Well, 3 doesn't equal 5. So once again, we're going to call the method. This time we're going to pass a 4. We find that 4 does not equal 5. So we're going to call largest again, and we're going to pass 4 plus 1, which is 5. So now when we do this method call, we see that 5 does equal 5. So that means we're going to return list 5, which is 4. So 4 is the largest item in that sublist. So now we're going to go back to our previous call. So we're going to compare list 4 with our maximum. So list 4 was 9, and our maximum was 4. So we're going to return 9 since that's the larger of the two. We'll then go back to our previous call where we're going to compare list 3 with our current max. Well, list 3 is 10 and our maximum is 9. So since 10 is larger, we're going to return 10. We'll then go back to our previous call where we're going to compare list 2 with our max. Well, list 2 is 2 and our max is 10. So since 10 is larger, we're going to return 10. And then we're going to go back to our previous call from there where we're going to compare list 1 with our max. List 1 is 8 and our max is 10. So since 10 is larger, we're going to return 10. And then we're going to go back to our original call where we're trying to find the largest from 0 to 5. So we're going to compare list 0 with our max. List 0 is 5 and our max is 10. So since 10 is larger, we're going to return 10, and that is going to be the final answer, the largest element of our entire list.